In section 8.3, we're comparing populations, and we need a way to compare them, and your book has chosen two different types of data displays. The one that we're going to focus on today is called a box and whisker plot. Has anybody even heard of them before, a box and whisker plot? It basically divides your data into 4 parts, okay? And well, let me go ahead and just move on to the next slide, and we'll start talking about what each one of these mean. Okay, so mean and median, those terms are familiar to you. Okay, but how does it apply to what we're doing in the lesson today? Well, we have to look at this word called an outlier. Can anybody kind of guess at what that means? What do you think an outlier is? Something that occurs far outside of the rest of the data. So it's a value that is way outside the cluster of values like inside a data set. All right, so if you have outliers, you're not going to use the mean. So I'm going to show you how to look at a box and whisker plot and determine if there are outliers. Can I tell you, most of the time you're going to have them? You're going to have outliers, all right? That's pretty common. So most of the time you're going to use the median. That's the most accurate measure of tendency when you have outliers, okay? All right, so let's say you don't have outliers. You would use the mean and the mean absolute deviation. I don't even need you to write that down because that's not the one we're going to focus on today. Right? When you do have outliers, you're going to use the median and the interquartile range. Basically, the range of values, we find range by subtracting values in a box and whisker plot, okay? You need to know interquartile range stands for IQR. You're going to hear me say that a lot today, IQR. You know that that's the interquartile range, all right? When information is skewed, and like I said, it normally is not cut and dry. Like, hey, here's your cookie cutter list or data set. Usually there's values that fall outside of, of a certain range, all right? So that's why we use the second method, median and interquartile range.
Yes, no?
All right, so in example 1, okay, you don't have to draw this, all right? I just need you to read it, okay? So on our classwork today, you don't have to copy the original problem. That would take you forever. But we are going to read the information here, and we have to know what we're looking at, okay? So as you could probably guess, the box that you see here in data set A, that stands for the box part of the box and whisker. And then pretty much exactly how it sounds, the whiskers are the lines that extend out from the box, and the whiskers show you basically this last point, okay, this far outside point. This stands for a value that is in this data set, okay? So you can tell based on how long the whiskers are that you have outliers, okay? Now this is important. You need to write this down. About 50% of the data is inside the box. Okay? The box part of the box and whisker plot. Okay? Now, in total, on both sides of the box, the other 50%, or about a quarter, 25%. All right? Or on either side of the data box. Whiskers. Data is in the whiskers. All right, and that's important. You'll see as we kind of get into some of these questions where that would be important. Okay? All right, so does everybody kind of, you're following along with me, get the box and you get the whisker part, and then the points on the very ends, those are our outliers. If you have long whiskers, okay, if you have long whiskers, that means you have an outlier. All right, you guys with me so far?
Yes.
Okay. All right, so now let's answer some of these questions. It says, here's my first question. compare the data sets using measures of center and variation. So I kind of gave it away here. I told you it's the median, okay? But again, why is it the median? It's because I have these outliers out here. If I try to use the mean, then it's not going to be accurate because of the outliers. So it is the median, and the box and whisker plot actually just comes out and tells you what the median is. You just have to know what you're looking for, okay? And here's where the median is. It's the point in the middle of the box that has a line through it. That point tells you what the median is. You just follow it all the way down to the value that it is on the number line. So the median for data set A is what, class? 60. And the median for data set B is 90. Not so bad once you know what you're looking for. You're like, say, what? Okay. And now it's as easy as this. To compare the measures of center, which data set has the greater measure of center? No.
B.
Which data set, A or B?
B.
B. So here's two ways you can compare them. You could say data set B has the greater measure of center. Sounds all fancy. All you're doing is looking at the values. Or how else could you say it?
B's bigger.
Well, that's what we already said.
It's less than B.
Data set A is less. That's all you have to say. Okay, so to compare the measure of center, I would say data set B has a greater measure of center. Doesn't that make you sound so smart? Okay, but all we're saying is it has the greater median.
Could we just put B's bigger?
Come on. Sounds a lot more fancy if you say it my way. Okay, now let's talk about IQR or interquartile range. I'm still looking at the data within the box because remember guys, most of the data is inside the box, okay? So what I'm going to do is try to calculate the range of the data. So for data set A, I meant to make that a highlighter. What value is the far right point on that I just highlighted? What value does that match up with? 80. And what about the far left of the box? 30. So what I'm going to do to calculate my IQR is 80 minus 30. 50. Okay? Interquartile range. I'll explain more in a minute what that means. Okay? Now for data set B. Okay? I need to calculate my IQR. Okay, so just take your outside points on the box. What is 100 minus 80? 20. Okay, so now I need to compare the variation of both data sets. Basically, what does that mean? How much or by what quantity is the information kind of, I'm going to use the word varying, outside of the measure of center or the median, okay? So which one has the greater variability? Which one has the greater variability? Yes, it's A, okay? So 50 is greater than 20, right? Okay, so I'm kind of stating the obvious, but I'm saying that within the box, all right, those values inside the box can vary farther outside of my measure of center, my median, okay? So I'm just going to put that in words. All right, data set A has greater variability. And no, you can't say A is bigger. Okay. All right. Variability. How are we doing so far? Not too bad. Okay, I know it's different. I know it's new. All right, just try to hang in there. All right, now let's answer the next two questions. All right, next question. Which data set is more likely to contain a value of 95? So again, this part you're not necessarily going to write on your notes. Let me just kind of erase what I wrote up here so we can start over. All right, now on the number line, does everybody agree 95 would be about here on the number line? Does everybody agree? Okay, so we're going back to where is most of the data? It's inside the box, okay? So does everybody agree that if the value is on 95, it's actually going to be out here in the whisker somewhere on data set A? Does everybody agree? And on B, where's it going to be? Inside the box. So because 95 is inside the box on B, I'm going to say that data set B has a greater chance of having a value of 95 because it's inside the box. So what if it was inside both boxes?
What is it closer to?
It's going to be both. It's going to be an equal chance. What if it's inside neither box? It's still going to be an equal chance. So really, the only time you can say it has a greater chance is if it's inside one box but not inside the other. All right, so I'm going to say box B, or data set B. Data set B. Okay, so now you answer on your paper, what do you think about the value of 70? Don't say it out loud yet. All right, which data set is more likely to contain that value? Don't say it out loud yet. You just write it down on your notes. What is it? Data set A, definitely. Okay, so I'm down here on 70. Well, if I'm on 70, it's inside the box here, but it's on the whisker for B. So again, there's more data inside the box. So it's more likely to occur inside data set A. All right. Okay, so now let's talk about the variability. That's what it's saying here when it says differs from center. We're talking about the variability. How far does it go outside the center? What was the center? What do we call it? Starts with an M. Median. Okay, no, not the mean. We have outliers. Okay, so how far could it differ outside of the median? Okay, by at least 30. So which data set, now we're looking at the IQR. Which data set is more likely to contain a value that differs from center by at least 30? Okay, so my center, let's look at data set A, is 60. If I go 30 to the right, I'm outside the box. But what happens if I go 30 to the left? I'm technically still inside the box, and based on the IQR value here, it's 50. My IQR for data set B is only 20. Well, I need it to vary by 30 outside the median. It's definitely data set A. Okay? So if you need it to vary by a lot, and 30 is a lot, you need to pick the data set with the greater variability. Okay? Data set A. Okay? Now, this next question gets to be, without knowing how many numbers are actually represented here, it's kind of hard to say, but what if I said data that's no more than 3, okay? Well, let's just say, for example, that there are 50 numbers inside the box. 50 numbers here represented, and 50 numbers here represented. Okay, that's a lot of numbers, right? So if I wanted to vary by no more than 3, that means there's a lot of numbers packed in around the 90 on data set B. Would you agree? And probably there's a way bigger range here. I mean, who knows? I could have numbers down in the 30s as much as I could have numbers closer to 60. So there's a greater chance. All right, now again, it's kind of hard to say not knowing how many numbers are represented, but because I need a tighter variability range, it's definitely going to be data set B. Am I losing you guys? Okay, hopefully you're following along with this. All right, data set B is going to be my choice for no more than 3. Okay. All right. We are just about done. I just need to cover one more concept. Okay. And then we're going to kind of repeat that a little bit. And then that'll be it. But guys, this is what we just did on this slide. This is what you need to know. This is going to be on your quiz. This will be on your test. You need to find the median. Can you find the median on a box and whisker? Okay, that's going to be on there. Can you calculate the IQR? And then can you answer some questions based on that? Okay, it's going to take some practice. We're not having our test tomorrow. All right, so it's not until Wednesday. All right, any questions? All right, example 2. Okay, we have amusement parks. All right, who of you guys in here? Okay, please just raise your hand. Don't talk. Okay, who of you guys in here? You go into an amusement park and you're like, "What's the tallest and the fastest roller coaster I can find?" Okay, so basically, all right. How many of you hate roller coasters? Anybody? Hey, that's me. I know. Okay, so here's what this data is showing, guys. Listen, it's really important that you know how to read a box and whisker plot. This data shows the heights of the roller coasters at 2 amusement parks. The heights, not how many. There's not 70 roller coasters. Okay? It's the height. Listen, it's the height. Listen. Okay? So on Park A, and again, because we have an outlier, and I'm just telling you right now, there's going to be the outliers, so we're going to focus on median and IQR. All right? Based on this data, if there are outliers, the data is skewed. And the reason I'm saying that is because that tells me I have to use median and IQR. Okay? So is the data skewed? Yep, it is. Okay? So now, based on that, let's identify, based on the fact that data is skewed, let's identify the median for Park A and the median for Park B and the IQR for both parks. Go ahead and do that. What is the median for Park A? I think you're supposed to go too, yeah. Okay, guys, it's the middle point with the line going through it. Okay? And what value is that on? Follow all the way down the number line. What's the median for Park A? 50. Okay? So you're going to write 50 for Park A. What's the median for Park B? Okay, right where the line's going through it, it's 55. Okay? Do you see how we found the median? So, guys, hey, the good news is you're not putting anything in order and crossing it out to find the middle. You just have to know how to read the box and whisker plot, and there's your median. That's it. Now, how do we calculate IQR? It's the... Subtract the 2. Yes, subtract the 2 points on each side of the box. So 55 minus 45 is 10. And what is it for the second? 10. 60 minus 50 is also 10. All right, so would you agree that the variability of the heights of the roller coasters is pretty much the same? That's what the IQR is telling me. Okay, so here's the question, all right? In your book, your classwork will present this question this way. Is there a significant difference between the 2 parks and the heights of the roller coaster? Okay, is there a significant difference? Well, first of all, we have to define what is significant. Okay, all right, so here's your definition, and I'm on the top of page 340. Okay, when the difference, what does it mean, difference? Difference. I'm on the top of page 340. When the difference, when the difference of the medians, that's my measures of center, is 2 times the measure of variation. All right, it's 2 times, so that's what I mean by 2x. That's bad. I'm going to say 2 times. 2 times the measure of variation. Okay, that's significant. That tells me what's significant. What is the difference in the medians between the two parks? No. What's the difference in the medians? 55 minus 50 is 5. Okay, what was my IQR? 10, my variability. Is 5, listen, is 5, what's 2 times of 10? 2 times 10? Double. That's not 5, okay? So because it's not 2 times the variability, it's not significant, okay? 5 is not twice my IQR. My IQR was 10, so that number, the difference in the medians would have had to been 20, okay? So that's what it's saying here, okay? That's what it's saying here. So no, because the difference in the medians was 5, that is not double the IQR, so no, not significant difference in the height. Now, what if I just said, I want to go to the theme park that has the tallest roller coaster between A and B? Which one would you go to?
B.
What?
Yes.
No, the tallest, the highest. Look at the outliers. Look at the whiskers. Yeah, A. Yeah, that point says they have a 70-foot roller coaster. Now, I would say a lot of their other roller coasters are kind of kiddie, all right, because they're a lot shorter than the average, okay? But then they got this one, like, giant one, okay? So, anyway, if you want to ride a lot of different ones that are exciting, Park B might be your choice. Okay, so because the difference in the medians was only 5, it had to be twice the IQR, and it's not. It's only half the IQR. So if somebody said half, that's what it's saying there, that 5 is only half of the IQR. It's not double. Okay, so that's why it's not significant. All right, now I'm just going to, 2 more slides, but we're just kind of, again, reinforcing this whole idea of median and IQR. Okay? And this is actually 8.4, okay? So in 8.4, this statement over here, and guys, I'm right here in your book. I actually just cut this straight out of your book, okay? So I'm on page 344. And this makes sense, doesn't it? You're more likely to make a valid comparison. Here we go again with biased and unbiased. When the sample size is what? Large. It doesn't make sense. We talked about it. If Jacksonville has 1 million people, you can ask 10 people and say that's the opinion of all of us? No. Okay? It's got to be large enough. And little variability. All right? So what do we do here? Okay? Here's all we're doing. Because of these outliers, I'm going to use median and IQR. Median and IQR. So for bag A, my median was 4. And then how do they calculate IQR? What do we do again?
Take the 2 out.
Take the 2 outside. 6 minus 3 is 3. Okay, and did the same thing for bag B. All right, here's where, I think it's like, what's the point? They talk about in your book that the answer to this question, can you determine? You actually can't. So you did all that work and you actually can't determine, based on this sample, which bag contains tiles with greater numbers. Because why? How many did they sample?
Oh, 9.
No, look up there.
Oh, 12.
12 out of how many?
1,000.
Sample size isn't big enough. Okay? It's not big enough. It's not even close. Okay? So, and that's what they say right here, like on the page. The sample size is too small, however, to include that bag A generally has greater numbers. Okay? Sample size is too small. So what do I want you to take from the slide, and why am I even showing it to you? Because you need to know how to read a box and whisker plot, find the median, and the IQR. Can you do that?
Yes.
Okay. All right. Same thing with the last example. All right. Now, the reason I'm showing you this is because I need you to be able to answer a question. Not necessarily, what if I were to just give you this information? Okay? So I've taught you, up to this point, Okay, yeah, the middle point, yeah, it's about 54. You can follow the box and whisker plot. And the median for state B is 70. But what does that mean? Okay, so let's read back on the example. The double box and whisker plot shows the medians of 50 samples of speeding tickets. And there's 10 speeding tickets represented in each state. Compare the cost. So these are cost. So what it's saying on the median number here, this is about, on average, how much a speeding ticket cost in state A. And this is about how much a speeding cost in state B. You've got to be able to read the problem and figure out, and it tells you. So which state would you rather get pulled over in?
State B. I mean A.
Yeah, state A. All right, so answer the question. Compare the cost of the speeding tickets in the two states. Compare the cost. There's a lot of different things you could say, right? Speeding tickets cost on average more in which state?
B.
State B tickets cost more. Okay? You could say state A has the lowest cost for a speeding ticket. Like you can see that their outlier goes lower. Okay, so that's another conclusion. But on average, state B speeding tickets cost more. Who knows? Maybe they have a lot of hills and people get caught on the downhill. Who knows? Okay, but for some reason, their speeding tickets cost more. All right, if you understand that, that's everything you need to know for 8.3 and 4. We are done with chapter 8. I would say the first two chapters, sections of the chapter, there's probably more information in there that you'll be tested over. But what is some important information here? Median, IQR, and answering questions, okay? Just like we did in example 1 and in this question where you can compare. I'm going to be asking you to compare and to tell me which one is greater or less and whatnot. Okay? All right, that's everything you need to know.